started?
Yeah, sure. Yeah, go ahead.
Okay. Hello, everyone. Welcome to my thesis defense for graph-based approach to studying the spread of radical sentiment. So as an overview, I'm going to go over the motivation, the approach, research questions, and scope of this project, and then go through some related work, background, and some existing models for what we're doing, and then go over the data set, experiments, and results, and finish off with some analysis and conclusions. So I'm first going to start off with some headlines. Unfortunately, in America today, we're living with acts of terrorism. We have a lot of domestic terrorism, a lot of lone wolf terrorism, and it's something that has many facets to it. There's many reasons why this is happening, but all of these have one thing in common, which is all of these people were radicalized online. If we trace their motivation, we find that they go to some type of online board, right? And this is not an esoteric problem like this headline up here, the Buffalo shooting that's an hour away from us, that's our sister city. We know that shooter was radicalized online, drove to a Black community and started shooting because that's what people told them to do. So we're living in this new era of cyber social threats where we have some online extremist content, some radicalization process, and it leads to terrorism, discrimination, hate crimes. And this was an interesting study done by the US Department of Defense. They looked at the 15 years before and after 9/11, so turn of the century when the internet was coming to rise, and they found an exponential increase in the radicalization location from the internet. So, pre 9/11, before the 2000s, the internet wasn't that big, but then afterwards, we see an exponential growth in this online radicalization. I would like to see this study redone before and after the COVID era, because we've also been seeing a huge spike in radicalization online as our lives have, been taken to the internet more. But what we're trying to understand is this radicalization process. How does online content go and motivate someone to do real harm in real life? So we're going to focus on radicalization and do a little bit of overview on the online extremist contents, but it's not the focus of this talk. So the first tool we're going to use is sentiment analysis, which is a natural language processing, AI-driven way of looking at text and then determining what its sentiment is. So is it positive? Is it negative? There's even multi-class types of sentiment, so you can determine what kind of emotions come from text. And we're going to combine this with another COVID era model, which is the graph-based disease model, or a contact graph, where you have members in a graph and they're all connected to each other through some type of contact. We represent them with nodes and edges, and the amount of contact they have with each other is by this weighted edge. So what we can do is we can form inter and intra-thread graphs, where inter-thread, or between threads, is we're representing these threads as nodes, and they're connected to each other by shared members. So if there's two threads in a forum and they have shared members, they'll be connected in our graphs. And on a lower level, we're doing intra-thread, or within threads, where we're representing members as nodes, and they're connected to each other by the number of replies. And by combining these, we hope to study the spread of sentiment, almost like how you would study the spread of a disease. Uh-oh. The fire alarm goes off. Wow.
Well, I guess we
gotta evacuate the building. I will reconvene when we know the building's on fire. Impeccable timing. Sorry, everyone.
Wow.
Wow.
This is the first.
Yeah, this is one for the history books. Okay, be back in 15.
No, I think it's a joke. Usually when they do.
I think I can start off where we left for our imposed break. So research questions with our graph-based approach is, we want to know to what extent do connected members in an online comment thread and connected threads themselves share sentiment? And additionally, what's the impact on like the weights of this connection? We want to know the most influential members in a comment thread and how they shape the sentiment and the spread of the sentiment inside of the thread. We want to do a temporal analysis. We want to understand how these threads evolve over time as more people join and as make more comments and replies. And finally, we're going to see if we can make some type of model that can on the generalized behavior, so we can do some modeling. So for the scope of this thesis takes from many areas such as sentiment analysis, study of extreme speech, data collection, graph theory, and social network analysis. But all of these topics could be a thesis in themselves. Even looking at like the linguistic properties of extremist speech would warrant years of study. So really, we're just going to focus on the social network analysis. We're going to take a data set that's already been used. We're going to accept the claims from sentiment analysis and from the study of extreme speech, because especially for a master's thesis, we do not have time to look into everything. So now I'm going to go into the related work, background, and existing models. So we're going to go over natural language processing of extreme speech. We're going to go over social network analysis, and we're going to go over information diffusion and social contagion. So radicalism, radical versus extreme, they're used interchangeably, and there's really no consensus when they're used. But to be very technical about it, radical is just something that is, a movement against the establishment. It's contrarian, but not necessarily bad. So like an example is like, free healthcare education would be considered like radical in US politics just because it's against the norm right now. Whereas extremists or extremism is like an anti-democratic movement that stands against those who don't embrace their like dogmatic prescription to society. And further, we're going to say radicalization is the process of causing someone to adopt extremist or radical ideas. Just clearing up some terms before we go on. If we look at the trends in natural language processing on extremism, we see that there is a lot of focus on like religious jihadism and political far right. But as we see, this is cut off. This survey was done like in 2021, so it's cut off at 2020. But if we were to project forward, the slice of this would be way more focused on far right extremism, especially after January 6th, especially after all of our election stuff. There's a huge growth in looking at far right extremism. But overall, the trend is there is a kind of exponential increase in these papers using natural language processing to study extremism because of this online spread of extremism. And if we look at the landscape of this online extremist research, this is just the research questions from the literature review that I was going over to understand landscape. The hot topics right now are jihadi and far right extremism. There's a lot of common natural language processing techniques like word embedding, sentiment analysis, engrams. There's a huge push for machine learning to come in because that's coming about. And some software like Senti right now, all this software stuff with large language models, this is all already out of date. We're going to be using large language models in the future, so I'll kind of ignore the software side. And then available data sets, which is obviously the thing because we're trying to study extremism, which is actually one of the challenges in studying online extremism is just procuring high quality data to do it, because every broad media platform is highly, regulated. They have a lot of administrators and, they censor a lot of, extreme speech. So just going into the data limitations we could do a whole study on that. Some challenges are also model explainability. That's kind of a broader AI challenge because like if you say, okay, this model identified this as extreme speech, well, why did it do that? We don't know yet. We just kind of trust our models. Multi-language limitations, because extremism isn't just in English, it's in many languages, so we need to train models on different data sets. Again, I'd like to see some of this after post rise of large language models, because I think this landscape would look different. So future trends is there's an increased interest for political extremism. Like I said, especially after January 6th, the government, especially the US government now, is really looking into that far right extremism. Use of deep learning models. We should probably add transformers in there too now. And multivariant classification models, which is using multiple NLP features. So not just sentiment, but also embeddings and semantic and syntactic features. So as a summary of online NLP extremism study, you kind of have the broad field, and it splits into language study and modeling, where the language study is looking at the sentiment and semantic like artifacts that are within extremist speech, so we can tell like what are the properties of extremist speech, when does speech become extreme, and questions like those. And then the other branch is really modeling, where it's like classification of, is this extreme speech, or prediction, is this speech going to turn extreme? And that's kind of the landscape that people are studying. We're mostly going to be aiming towards the modeling, but we will take lessons from the language study. But language study in itself is not our concern. And next, we need to go into social network analysis. So we all interact with social networks. They could be online, in person, but really when we were talking about social networks here, it's a graph, like I explained earlier, where there are people in it and they're connected. They're the nodes in the graph. They're connected to other people with edges that show their relationship. So you can think of this as just like Facebook, Twitter, 6 degrees of separation. This is all a social graph we're representing ourselves as. And then further, a social network in graph theory terms is a graph of U and V, where U is a list of social network users or entity, and V, the edges, show the relationship between our nodes in our graph. And there's a lot of applications of social network analysis. You can do community clustering, you can do information diffusion, you can identify influential spreaders within your graph, and you can also do temporal analysis. So for community clustering, you're finding groups of people or users with common properties, attributes, interests. You can use like graph theory to find these communities, and it has a range of uses. You can do like targeted advertising. You can find groups of related people and like, okay, advertise towards them. Or you can even, with your social network, you can have people link up with like people. And we can also identify influential spreaders. So along with information diffusion, which I'll get into soon, we can see how much information is spread from member to member of the graph and who is spreading the most amount of information, who is the most influential to the spread of information. In this thesis, we're going to assume that sentiment and information spread in a similar way. So they're going to be people who are dominating their network by spreading sentiment. Other applications, you can look at modularity, which is another community finding tool, which just looks at how well your network is going to break into pieces. And that can also look to find echo chambers. Like if there's a group and it's only connected to another group by like one connection, there's probably 2 echo chambers there. We can also use temporal analysis, which we will be getting into with one of my research questions, with how information spreads within a community and between communities over time. And now, as I said, I need to get into information diffusion, because now that we set up these networks, we actually need to look at information going through them. So information diffusion is the process in which information spreads from person to person or place to place, usually through some type of population. This is really a field that's been developed by advertisers and like marketing, because they want to make sure every dollar they put into marketing is hitting the most amount of people. So they've put in a ton of money to understand information diffusion to make sure they're getting bang for their buck. So the elements of information diffusion are, you have a sender, a receiver, and a medium. So you have someone sending information, you have someone receiving information, and you have wherever that's taking place. That could be in person, online, is it through text, is it through voice, and all these factors can be used to model information diffusion. And the simplest model, the first one developed, was the 2-step flow model, where you have some type of mass media, and then that mass media spreads its information to opinion or community leaders, and then the people closest to them get affected by the community leaders, and then it kind of propagates kind of in generations outward. So an example of this would be like, the new iPhone, whatever, the new iPhone 27 has come out, and they then advertise first to like, TikTok influencers, or like, influencers online. And then since they've advertised to the influencers, they don't need to worry about hitting individuals anymore, because that influencer will then influence everyone who follows them. So a more sophisticated model is the social contagion model. Social contagion is also a complete field of study, but for here, we're just looking at the social contagion model, which is similar to like a SIRS model or like an infectious disease model, where we get this classic S curve, where first an exponential amount of people get introduced to the new idea, and then there's some linear increase. And then as you start to saturate your population, this curve is going to flatten out because you've either hit everyone in the population with your idea or everyone who's willing to accept it. And this is a more nuanced model that can take into things like an adoption rate, the amount of people exposed or the exposure rate, and like a resistance or threshold. So some people might be resistant to your idea, and then how long would it take for it to spread to them? So now it's time to go into the data set we're using, our experiments, and our results. So first, to perform the study, as we said, data collection in this topic field is very hard because of how moderated most platforms are. So we use a data set that was used in previous research to similarly study online radicalization, which was a data set by the University of Arizona called AZ Secure, which is a collection of dark web forums focused on like jihadists speak. So they went to the dark web, they found some unmoderated boards where jihadi like type of comments were happening. And it is a mixture of benign and extremist speech. Some people were there just to talk about Islam in general, and then some people were there just to, spread heinous things. And we really had to process this data because it turns out that most of the comments made were not, as we would call, like active, like there weren't a lot of people commenting, or for the most part, the number of comments were like one. So someone posted a comment in isolation and it wasn't picked up. So we just filtered our data by, we want threads that have 30 or more comments in them, because we said that was like an active thread where we had many people, or not many people, it could even be two people, but we had plenty of interactions to actually deal with, because if it's too small, we're making insignificant graphs. So after processing, we're left with about 2,000 threads, and that's about 137,000 comments in total to look at. And also looking at the distribution of the data. So we're taking every thread and then finding the mean sentiment of that thread, and then just find the distribution. It is skewed towards the negative side, which would make sense given the topic. We're literally looking for extremist speech. So having a distribution that's towards the negative would make sense. So our first experiment was, as I described, we need to make these graphs out of these threads. So what we did was, for both the intra and inter thread levels, we represented each node as either a member inside of a thread or a thread itself, and then we connected them to other members, either literal members in a forum or other thread members, and connected them by some type of connection, either if they're inside of a thread, the replies they give to someone, or if it's between threads, the number of shared members, or if they share members between that board. And then we took the sentiment, either the overall sentiment of the person posting or the overall sentiment of that thread. And here we labeled and color-coded our sentiment so we can see who is connected to who and by what sentiment. So there are three types of connections that we identified. We have positive, positive, negative, 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 positive. So we're looking for, are people generally connected to people of like sentiment? Or is it the case that people are usually connected to people opposing sentiment? So our results for both the intra and inter-thread level found that the vast majority of connections in our network, about 75%, were between people of like sentiment. So about 75% of all of our connections in our network are between both weighted and unweighted. So either looking at unique connections between people or weighting them by the number of replies or the number of shared members. And we see that in our context, because we have a negatively skewed data set, there's more negative contact than positive negative contact, which I'll get more into the mixed connections later. So for our second experiment, we wanted to observe the most influential members in a thread and how they shape their overall sentiment. Luckily, since we are using graphs to represent this, we have a rich toolbox of graph theory to draw on. And the terminology that we use for like most influential node in a graph is centrality metrics. And here we used information centrality to determine the most influential person in the graph, because that's how much information flows through them and flows from them. So we can imagine that if information carries sentiment, then the person with flowing the most information is also going to kind of flow the most sentiment in their thread as well. And we also looked at who is making the most posts and what's the difference between the thread sentiment to the individuals. So looking at the number of posts made by the original poster or by all posters, or yeah, by the original poster and the distribution of central members, we see that the original poster is by far the most active and most central member in a thread. So they're making upwards of 60% of the comments in the thread. They're very active. They're kind of like managing the thread. And partly because of this, they're also becoming the most central member for information centrality, which if you look into like the calculation for information centrality, that means they have many connections. They're very well connected, and they're close to a lot of members as well. So it looks like the original poster posts their thread, and then they're very, invested in their post, and so they kind of maintain it and comment to everyone. Additionally, we looked at the difference between the mean sentiment of the thread and the original poster to see how much influence they could have over it. And it turns out that the mean sentiment of an online thread is actually distributed around the original poster. So it turns out that the original poster influences the sentiment the most, as well as, influences the most amount of members given their centrality. And we also wanted to look into OP or original poster central threads. So if the central member was not the original poster, what did those threads look like? And we found that they tend to be longer threads with less active members. So there's more time for people to make comments, but people are making very few comments. So it's fair to say if the original poster is not the central member, there really is no central member. The central member bounces around because people are not commenting enough to really take centrality in their network. So here we see in the original poster is the central member, everyone and the original poster is making more comments in a shorter thread. But if the original poster is not the central, they are longer threads with an average, people are making less posts. For our third experiment, we did temporal analysis. So we evolved our graphs in time, and by time we mean a thread interaction. So was a comment made or did a new member enter the thread is our time steps. And what we want to do is we want to evolve our graphs as people come in, comment, and see what happens to the sentiment of the graph, as well as look at how centrality shifts between people. So our results, kind of hard to see, but I had thousands of threads. So I just picked, I think, a sample of 25 for looking at the time series of the mean and standard deviation of the sentiment in that thread. These threads, they start out kind of chaotic when they have a low amount of members or a low amount of comments, because every single member or comment has more influence. But as they mature, we see that the mean sentiment and even the standard deviation of the sentiment starts to regress to a mean. As we get more statistics in there, it kind of stays steady after enough comments or enough members are added. And we know that from before that this mean is kind of regressing to the original poster's mean. And this, we're kind of backing up our results from experiment 2 by looking at the percentage of time as central member. And we see that the original poster or the 0th, member is dominating centrality over time as well. And further, with our experiment 3 results, we separated our threads by positive and negative starting a sentiment. And we found that the standard deviation when you had a starting original poster was greater than those with a negative original poster. So it seems like if you have a thread that's starting out positive, it's more likely to turn negative, which is also something we check the difference between starting and ending. So if we looked at the negative original poster distribution between the difference between their starting and ending sentiment, it is distributed near 0. So it's kind of that normal distribution we would like to see. But with the positive original poster, it's distributed around -5, which means that there is a tendency in our data set for these posts to start out positive somehow and then end up negative, way more than if you started negative, you're going to end negative. So for our last experiment, we're going to take all of the lessons from our previous three experiments, and we're going to create a model based off of our generalized behavior. So we're going to do two models. I mean, it's one model, and we're trying to apply it to two purposes, which is classification. So if you have a full network, like a mature thread, and you take out like a sentiment value from one of the members or one of the nodes and make it your target, how well can you classify their sentiment as either going to be negative or positive based off of their neighbors? And additionally, we want to take this and do like a contagion model where you have some network or some nodes and you add in a new member. Can you predict what that new member that's now entering the thread, what their sentiment is going to be? So for our first model, the classification, we want to test the validity of it by comparing it to a naive approach, which is simply a k nearest neighbor, where you tally up the sentiment of its neighbors, and whatever the dominant sentiment is, you're going to say that's the target sentiment. Again, we're doing this as kind of binary classification because a granular, like this is the exact sentiment, is a little bit untractable right now. And also we just want to know, does the negative sentiment, can it be classified, or the positive sentiment? And to beyond our native or naive approach of k nearest neighbor, we use a machine learning approach where we actually learned features from the graph, not just counted the neighbors, but we learned features like the sentiment of the connected nodes, which is the only thing that the naive approach sees. But we also looked at the edge weights to the neighbors, and we also looked at the centrality of that target node compared to the centrality of its neighbors. So we can see, is it connected to important people, or is it an important person itself, and use that to learn on. So for results for classification, our naive approach did not do any better than like random guessing, I would say. If it's like 50% accurate on a binary, classification, F1 score of 0.54, not that good. But we did a random forest approach on our actual features, network features, and it got an F1 score of 0.84. So the jump between just taking the naive approach and taking a machine learning approach is significant. So we would be confident saying that the features we found in our networks are significant features when it comes to the classification of the sentiment of speech, which we're kind of using as a proxy for finding radical speech. Now, further, we want to use this as a contagion model where we seed our classifier with n starting members. So it's like, do we want 1 starting member, 3 starting members, 5 starting members? So the model has something to work off of, but then it's like predict the next person based off of their connections. So now your target node is outside of your network instead of inside. And then it will repeat this until it constructs the entire graph. So it'll say, here's the next member, classify their sentiment. Okay, here's the next member, classify that until it goes all the way through the graph. So here's an example of an actual graph we had from our data that we constructed, and then a predicted graph from our model, which isn't perfect, but it's doing fairly well for what it is. And if we look at the results for the accuracy of this prediction for every single thread with n equals 1, 3, and 5 starting nodes, we can see as we add in more nodes, so it has more starting information, that it gets more and more accurate. But there is a tail here where there's like a class of threads that it cannot like really determine or predict what the sentiment is going to be. And I actually looked into this, and it's really for small networks, especially like the n+1 network. So if you're starting with a single starting node and you have a network of only 2 members, there's really not enough information for the model to go off of to predict that sentiment. But we're also kind of torturing this model to do something beyond what it was originally built for, which is, I think, a future work I want to do is create a specific contagion model, because here I just say, hey, this classification model works decent for in-network, can it predict out of network? And that's another kind of robustness check, like how well is it doing, or what are the important features if it's performing less well when it has less connections and less nodes. Obviously, having those features is important for that classification and therefore prediction. So this is just some of our results. We see our F1 score generally increases as we add nodes to the starting graph. It's not excellent, but this is more of a proof of concept, because as I'll go into an analysis, the traditional methods of figuring out, like classifying or predicting extremist speech, are all natural language processing based. They're not using any network features. And I'm trying to argue, okay, these network features are significant. Like we can classify fairly well using network features. So if you're not using them and only using NLP features, you are missing out on information. So now I'm going to go to analysis, conclusion, and future work. So sentiment classify, like I'm comparing the model features. So the traditional models, like I said, they use like a single class sentiment, multi-class sentiment, semantic patterns, word embeddings, but they use no graph or community features. So they literally look at comments in isolation. They don't take into account their neighbors or who they're connected to. It's just on comment by comment, looking at the raw text. Or I use single class sentiment of connected members, but I also use the graph and community features like edge weights of connected members, centrality of target, and centrality of connected nodes. So what I want to see in the future is this comprehensive model when we're looking at online threads of, yes, take in the whole gambit of like MLP like tools and features we have, and bring in these community features. Let's merge them together so we can get a rich feature space out of the text itself, but also a rich feature space out of the network that comment exists in. Because right now, a model like this doesn't exist. No one's been looking at these network features. They've only been looking at the text itself. And future work, definitely stance detection is something that needs to be put in a framework, because like, as I said, I was looking at positive, positive, negative, negative, positive, negative, but what does that mixed sentiment mean? Because you could have like a mixed sentiment where someone has posted a heinous, like extremist comment, and then somebody agrees with them a lot. So it looks like there's negative connected to positive sentiment, but that positive sentiment is now amplifying the negative sentiment. Unfortunately, this sentiment detection or stance detection is a very new field, and all the cutting edge models are not in a state that were usable to us without us putting significant effort in to develop our own model. Because right now, stance detection is really just a static target stance. So you can compare two comments to a single target, but you can't compare them to, or there's no like moving or like comparing just two pieces of text together that we could find anyway. More data sets, especially larger data sets, and probably data sets that are more balanced as well, because we need to check the robustness of our models and our analysis against, okay, we went in and picked out a data set that we kind of knew it was going to work on, or we knew that it was in our domain and we were like hunting for extremist speech to do a proof of concept that here's how extremist speech kind of behaves. But if this model is to be practical, it needs to go in on more general data sets like the fire hose that is like Twitter or Facebook or something, and be like, can you pick out and model extremist speech out of this when there's like way more benign mixed into it? And yeah, as I said before, incorporating the classic NLP features is something I'd like to do, especially looking at the spread of more features, because we only looked at the spread of single class sentiment, but there's also multi-class sentiment. You can do emotion detection. So we could find the spread of different emotions themselves, or even look at the spread of certain like semantic or syntactic patterns, because the most state-of-the-art models use this whole gambit of NLP features, and we could see if they spread as well. So conclusion for our first research question is: members in our network are connected to members with similar sentiment the majority of the time. For our second experiment or second research question, the original poster is by far the most influential member in the comment thread, and usually determines what the sentiment of that thread is going to be. For our research question 3, over time, the sentiment in threads regresses to a mean, and further, that mean is usually around the original poster. So as a thread matures, you'll see it behave more like the original poster. And for our research question 4, network features can be used to model the sentiment of behavior. We kind of did a proof of concept of like, okay, very little natural language processing. Let's just look at network features. It behaves fairly well. So for the broader impact of this work, we want to see it developed to shed light on the mechanism of online radicalization, because we can identify influential spreaders and we can model the spread of extremism. We can, have this inform people when they're researching online radicalization themselves, and use our tools and use our methods to further the research. Further, we hope this can be actually used to inform maybe terms of service. So if we know okay, the original poster is the person, the member that determines things. So you kind of need to stem the original poster if you detect extremism off the bat, and maybe even inform policy decision how we should govern our social networks, knowing how extremism spreads. And obviously some acknowledgements. So to my committee panel, my advisor, Nidir Stogi, we have Ashik Kudabush, who could not be here today. Unfortunately, he had a family emergency and had to fly home to India. So I'm recording this for him. Let's give him our best wishes. Andy Manili, and last but not least, Mohammed Mkawar. Thank you all for being my panelists, and thanks everyone for listening. And questions. Now it's time for the defense bar.